All right, so now what we're going to do is we're going to look at annuities and how they fit into loans and how the actual entire banking industry is really the two formulas that we've seen, the annuity formula and the interest formula. And we're going to see how that sort of comes together in the aspect of loans. All right. Now, just FYI, there are two different types of loans. There is a loan where you repay one lump sum at the end. Okay, a lot of the smaller loans can be dealt with this way, like the payday advance and those kinds of things. You're supposed to pay one lump sum at the end. Although I would not suggest anybody get those types of loans because oftentimes the interest rates are very, very high, and the types of things, the fees that you have to pay are enormous. So if you can try to get a regular conventional loan, it's a much better situation. Now, the vast majority of conventional loans are things where you repay every month or every year. Okay, so if you get and you buy like farmland, you typically have a yearly payment on that farm ground. If you go out and get a house, then typically your mortgage payment is a monthly payment. Now, when we say lump sum repayment, it's just like the present value that we learned earlier. That's all I'm saying is if the bank lends me, let's say $10,000, that $10,000 is my initial principal, right? So if they lend me $10,000 at 5% interest, compounded yearly, for, let's say, 5 years, how much you're going to owe them in 5 years? Well, that $10,000 that they loan you, that's the principal. That's the present value. 5% interest yearly, 0.05. You could say divide by 1, but that's fine. For 5 years. So multiply that all out. And you should get $12,762.82. So at the end of 5 years, you would owe the bank $12,762.82. And by the way, when I say it's just like present value, we can work backwards as well. All right. So if you can pay, let's say you can pay the bank $150,000 in 10 years, and the bank says, well, we'll charge you 4% interest compounded yearly over those 10 years, how much would they loan you today? All right, so I want you to try to figure out that and figure out how much interest the bank would loan you if you could pay them back $150,000 in 10 years. All right, push pause on the video, figure that out, and then come back. All right, so if you've done that, if we catch that, we know that this $150,000, that's our future value, that's our amount that you're going to pay back. So what we're looking for is a present value. And if it's 4% yearly, then it's 1 plus 0.04 divided by 1, although you could just put 0.04 there. And 10 years, once per year, means an exponent of 10. Remember that when you're doing this, try to put this in your calculator all at once. So you're going to take the 150,000 divided by 1.04 to the 10th power, and that's going to be your present value, or how much the bank would loan you today. All right. So what they would do is they say, oh, you can pay us back $150,000 in 10 years. Well, I'm going to loan you $101,334.63. All right. So that's how much they'd loan you today if you could pay them back $150,000 in 10 years. Now, banks don't typically do that. And there's good reasons for them not to do that, because anybody would walk in and say, well, yep, in 10 years I can pay you $2 million, and then all of a sudden 10 years comes down the road and you don't have their money, okay? And so what happens typically is that banks do a repayment over time, where you pay a yearly amount or you pay a monthly amount. And so we get this idea that we're going to do a payments over time plan. And this is how the vast majority of loans work. All right. Now let me do a diagram to make this a little bit easier. Now the bank is going to loan you a certain amount of money. All right. And they're going to loan you essentially what comes down to a lump sum. I'm going to call this, let me call it a P. All right. And if they had investments, basically they're investing in you, all right? So they're thinking of this lump sum as gaining interest over time, okay? And there's going to be some end amount over here. This is the final amount. So this is a lump sum calculation. Now, they don't trust people, again, to just pay them this end amount. So what they're going to do is, instead of paying this end amount, what they're going to do is they're going to set up a payment schedule for you that you're going to pay them all throughout this time until you get to the final however much time there is. And so what they're actually going to do is they're going to trade you a lump sum for an annuity. Okay? And so that's the diagram to keep in mind throughout all of the next few questions. And in fact, that's a diagram that you should know. All right? We have a present value. This is basically, this P is the loan amount. All right? And they're seeing that as an investment in you. So instead of you paying them at the end, which would be this final amount, they're going to make you pay an annuity. Now, like I said, the annuity is going to have the same rate of interest as this lump sum. So the interest rates for this path and this path are going to be the same. And it's going to be such that the annuity, when I calculate the final amount of the annuity, it's going to be the same as the final amount of the lump sum. All right, so there's two types of questions you can ask. One is, how much would the bank loan you if I were given an annuity? And the other is, what should the annuity be if you want to have the bank loan you a certain amount, like $150,000? So we're going to start with this first example. If you have a repayment plan of $1,000 per year for 10 years, and you have 5% interest, if that's the bank's going rate of interest, how much would the bank actually loan you? Well, again, remember this diagram. So, my annuity is going to lead to some final amount. And that's going to be the same amount as what we do for the lump sum. All right? So what we're going to do is we're going to use the annuity to calculate the final amount. And in this case, my repayment plan is $1,000 every year for 10 years at 5% interest. Now, since we're doing this per year, it's a yearly interest rate as well. So it's 1 plus 0.05 divided by 1 for 10 years. Do the minus 1 divided by 0.05 over 1. So punch that into your calculator. And what I got is that final amount is going to be $12,577.89. Okay? Now that is the final amount. This is this amount, $12,577.89. Right? So how much they would loan you is the principal. It's this amount, right? The starting amount up there. I know it might be a little bit hard to see in the blue. So what I need to do now, once that I found the final amount that I'm going to have to replay, I'm going to have to sort of backtrack to get the principal. Notice this is just a present value problem. I'm saying I want the final amount to be 12,577.89. Find the principal that would lead that to me. So again, this is 5% interest yearly for 10 years. So if I take 12,577.89, divide that by the 1 plus 0.05 to the 10th, 12,577.89. I will see that for that annuity, the bank will loan me $7,721.73. All right. So basically what we've done is we've gone back to this amount. We've taken our diagram, which almost is just a very simple drawing of two line segments, but it does help us understand this. We go from an annuity, in this case, to the final amount. Once we know the final amount, we can backtrack that to get what they would have loaned us. All right? And in this case, they would have loaned us $7,721.73. All right, so what I would like you to do is let's just switch a couple of numbers here. We're going to take example 1, and I want you to have a repayment plan of, let's say, $5,000 per year for 20 years at 5% interest. And say, how much would the bank loan you in this scenario? Okay, so push pause on the video, calculate this on your own, and then come back and see if you've got it right. All right, so I'm going to do this on this new piece of paper because it's a little bit cumbersome in that little space. So again, this all comes back to this diagram. Lump sum, annuities. This is the final amount. All right. So we had $5,000 for 20 years at 5%. That's $5,000. That's what's going into our annuity, right? And so, first off, calculate the amount that'll give you. The end amount of the annuity, right? The annuity is right down here. Take $5,000. We were at 5% interest on a yearly basis for 20 years. My pen is kind of, let me actually erase that and come back. Looks awful. So, 5% interest, 20 years. My annuity looks like that. Once you calculate that, I'm not going to spend a lot of time on calculating. That is 165, 329 and 77 cents. So that's this final amount over here. That's the amount, 165. That's where that 165 comes from. Okay? And so all I have to do now is say that, okay, 165 needs to be my end amount. What should the initial amount be if this were a lump sum? So 165, 329,077 cents is my principal. 0.05. This is over 20 years. All right. So take 165, $329.77 and divide it by the 1 point, right, dividing both sides here by 1.05 to the 20th power. And what we see here is that in this case, if for $5,000 per year over 20 years, the bank would loan me $62,000, $62,311.05. All right. So if I told them I'm going to pay them back $5,000 each year, and we've decided that 5% interest is the right rate, then waiting 20 years, they would loan me $62,311.05. Okay. So again, it's kind of nice to see in the diagram. You should know how to draw that diagram, by the way. You should know how to draw that diagram. You'll have to do that on the quiz. And be able to actually do the calculations as well. So here's what I want you guys to do. I want you to try to reverse that process. Okay? In this case, I know that I want a $150,000 loan. So again, we'll do my diagram. I know I want a $150,000 loan. And I know I can get, let's do 10 years at 5% interest compounded yearly. So I know I can get 5% interest from the bank, and I want my loan to be 10 years compounded yearly. So you can ask what the payments on the annuity would have to be to get you a $150,000 loan. So I want you to try to figure that out. Push pause on the video, at least calculate the amount, and then go back and see if you can figure out how to calculate the payments. All right, so hopefully you've done that. And let me calculate the amount first. The amount is going to be the final amount. The amount here, final amount, is going to be $150,000. Since we have 5% interest compounded yearly, that's 1 plus 0.05 or 1.05 for 10 years. So 150,000 And you get that final amount is $244,334.19. Okay? Now I want to backtrack to my annuity. Okay, this is the end amount of my annuity. So what you can do is you can set up the annuity just like we did present value problems. We have this is our end amount, that $244,000 is our end amount. And so we'll set that up with our annuity in mind. Now since I don't want to write, I'll write on a new piece of paper. This $244,334.19. That's my end amount. I want to figure out what my payments would be. Now, in the annuity formula, my payments are the P, right? And so, but everything else is defined. We have 5% interest over 10 years compounded annually. And we're dividing by a 0.05. So, by the way, let's. I'm going to do this with doing a little bit of rounding. I'm going to calculate whatever this number is. Okay, whatever this this number right here is, this whole thing. So I'm going to calculate this whole number. And if I punch in all that stuff, you should get that you have about 12.57789. Now be careful, you do not want to round this very short. You want to get a lot of decimal places because you're going to be doing the same process. If you remember the process that we had earlier, we're going to divide both sides by 12.57789 divided by 12.57789. So take that $334,334.19 divided by 12.57789. Like I said, you don't want to round that to 12.6 because you will get a different amount. But if you round it to about 5 or 6 decimal places, then it's going to give you a fairly close amount to what the real thing is. So anyways, I got a P of, well, what is that? $19,425.69. All right. So basically, if you want the bank to loan you $150,000 over 10 years, then you're going to have to pay them $19,425 for 10 years straight. Okay? And so that's your payments. That's your, in this case, they were yearly payments. So it looks fairly high, but that's because they were yearly payments, remember. Okay. All right, let's switch some things up. Most loans on, let's say, a house aren't for 10 years, and they're not compounded yearly. Okay? So what we want to do is this time we're going to compound per month. So we're going to compound per month. In the last example, I think it said per month, but I did it per year. And let's not do for 10 years, let's do for 30 years. A 30-year loan is a fairly standard loan. Okay? So what I want you to do is compound payments per month and do this for 30 years. Push pause on the video and then come back and try it and see how I did it. All right, so it's the basic same calculation in that, in that a $150,000. So the diagram looks very similar is what I'm trying to say. And we still have our annuity here. Annuity. This is our lump sum. And this is the final amount. Okay? So again, the bank is trading us this $150,000 lump sum payment into us for an annuity. And the $150,000 lump sum payment is going to end up, this is 5% interest. We're going to compound per month. So 0.05 over 12. Since we do this for 30 years and we're compounding monthly, my exponent is going to be 360. So that's going to be your end amount, right? So type that in, 150,000. 1 plus 0.05 divided by 12. We're taking that to the 360th power. And you should get that your final amount here is going to be $670,161.65. Okay, that's the final amount. Now we got to go calculate these payments for the annuity. And again, I'm going to deal with this on a new clean slide so that things go a little bit nicer. All right, so annuity. First off, we have $670,161.65. That's how much the final amount is on that $150,000 over 30 years. So we want to find payments. We're going to go 5% interest, compounded monthly for 30 years. So that's 360. Subtract 1. Divide by 0.05 over 12. Make sure that you put that 0.05 over 12 in parentheses when you type it into your calculator. I'm typing in my calculator. By the way, that's 360 is your exponent, even though it's written not so well. And what I got was 671.65 is equal to your P, your payments, times this amount, 832.25. Remember, I said go to few decimal places, 8635. All right. So take $670,161.65, divide it by $832.25, not dollars, excuse me, 832.258635. And what you will get is 805.23. Now that is going to be the monthly payment on a loan worth on a loan of $150,000 at 5% interest from the bank. So $805.23 every single month for 30 years. Now, just as a side note, $805.23 for 30 years at each month, that's 360 times. Gives you $289, $882.80. So technically, you will have paid almost $300,000 on a $150,000 loan over the course of 30 years. So that means in interest, you will have paid $139,000. I'll write this down. So the total interest, that's the amount above the 150,000, is going to be $139,882.80. Okay, so just take 150,000 and subtract it from 289,882.80. So you're going to pay an awful lot of interest on a 30-year loan over the course of 30 years. And you should know that in a 30-year loan, you're charged quite a bit of interest. At least at 5% you are. And if you went to a 15-year loan, you'd see even though your monthly payment was higher, over the long run you'd be charged less interest. Okay? So most generally, you try to get the shortest loans possible that you can afford, obviously. So, anyways, that was how loans work, and I hope that you saw, this important diagram. I'll draw it one more time. That we have an annuity here. We have a lump sum, and we have an amount. So what the bank's doing is they're trading you off. The principal on what they calculate is a lump sum investment for an annuity, which gives you the same amount in the end. All right? And that's how all banking works, basically. There's a lot of fancy formulas you can memorize, and if you look up a financial mathematics book, there's a lot of when they talk about the finance part, they give you some other sort of fancy formulas to go from here and skip going 2 steps, but going 1 step in sort of a longer formula. But I want you to understand the concept. The concept, again, is the bank is trading you a lump sum investment for your annuity. All right, the annuity that you pay them. Okay? And I think this is a little bit easier to comprehend than some of those ugly looking formulas in some financial books. All right? So that was the annuities, and that concludes the last section of the first unit.